The next question was about pedigree analysis and how to basically do it. So here are the basic steps. So one, you're going to make your first guess. What type of inheritance pattern do you have? And I'll tell you more about that in a second. Two, you want to check your guess, and I'll show you how to do that. And then three, if your guess is wrong, you have to try again. Only if you have to. Obviously, don't do it if you don't. So what should your first guess look like? First off, for X-linked, we're only going to be doing X-linked recessive. That's all we've done in this class, not X-linked dominant. So if you have an X-linked recessive, you're going to see it more often in males than in females. You're going to generally see it passed on from mother to son. So the mother has to be a carrier to pass it on to her son. All right. What about for a recessive? So autosomal recessive. For these, you're going to see them skipping generations sometimes, unless they're very common. And in particular, you're going to see that some individuals that have the trait will have parents that don't have the trait. And this is something we're not going to see with dominant. So for our autosomal dominant, we usually are going to see them in every generation. This isn't always true, but a lot of times we will. We're going to see that anyone who has the trait has at least one parent with the trait. Now, these aren't hard and fast rules. Well, this last one is, so for dominant. That one is a hard and fast rule. But the other ones aren't hard and fast rules. That's why we call it a first guess. So I want to look at one example, pedigree. And I'm going to make it a little small so I can keep everything on here. But here we're going to have a female crossing to a male, and neither of them have the trait. And they're going to have 3 children. So one of their children is a male who does have the trait, a male who doesn't have the trait, and a female who doesn't have the trait. She's going to cross with a male who doesn't have the trait, and they're going to have 2 children, a male who does have the trait and a female who doesn't have the trait. Okay. So what kind of pattern could this be? Well, we see it only in males, and we do see it, we call this skipping generations, sort of, because we have parents who don't have it, have a kid who does have it. So this is going to suggest that what we're looking at is an X-linked recessive. And now we have to test it out. That's our first guess, but we still have to check our guess. And how we check it is by writing into our diagram what we think it is. So we're going to guess as X-linked recessive, and we're going to test it out. If it's an X-linked recessive, then every male who has it has to be an X star Y. So an X star would mean that you have the allele for the trait. So here's another X star Y. Okay. And every male who doesn't have it must be an XY. They have the wild type version of the X chromosome. So now let's see if we can make sense of this pattern, if we can come up with females that will give us this exact pattern. So let's start with this female here. Now, she has a son who is X star. That means that she must have an X star, but she doesn't exhibit the trait. That means she must be X star X. Okay, so that works so far. And he got his Y chromosome from his dad. So we've covered everything that he has. Well, now look to see at her parents. So she could have gotten this X chromosome from her dad. And she would have had to get this X star from her mom. So X star, her mom does not exhibit the trait, so her mom must have one wild type version of X. Well, let's make sure that this cross here can give rise to the other two offspring. Well, the males are going to get one Y from their dad, and they're going to have to get an X chromosome from their mom. And that works because this X can be here, and this X can be here. So we have all of our chromosomes accounted for. We just have one leftover individual. We've already decided it's X-linked recessive works fine for this pedigree. Let's think about this individual here. Now we know she got an X chromosome from her dad, and she could have gotten either an X star or an X from her mom. This is what she got from her dad, and this is what she got from her mom. And Mendel's rules tell us that this is going to be 50-50. So that means that she has a 50% or a 50% chance of being X star X, where this is from her dad, this is from her mom, and a 50% chance of being XX, where this is from her dad and this is from her mom. So she has a 50% chance of being a carrier and passing this down potentially to half of her sons.